This playlist deals with some aspects of Eurocode 2 version 2023. Watch this playlist for further selected topics. This video will deal with Clause 8, the ultimate limit state, and it's the first video concerning punching shear. Punching shear is dealt with in chapter 8.4, and I borrowed a lot of information from the reference that is noted here at the top right corner. Concerning punching shear, there are different failure modes, and the first failure mode is failure within the shear reinforcement zone. So this is the shear crack, and this is the shear reinforcement. The second one is a failure outside the zone of the shear reinforcement, like it is indicated here. And a third one is failure by crushing of concrete struts. Let's take now a closer look to the failure mechanisms. On the x-axis, you have the rotation C, which is mentioned here. That's the angle. And we have the total force V. Now you can have, when you increase V and you measure the rotation, you will have a load rotation relationship, which is this one. Now you need a failure criterion, but for punching you have different failure criterions. The first one is, for instance, a failure criterion mentioned here for members without punching reinforcement. The blue one is a failure criterion for concrete crushing, like we've seen here. The gray one is a failure criterion outside the shear reinforced region. And the red one is the failure criterion within the shear reinforcement zone, as mentioned here. So you have different criteria for a certain load rotation relationship. We look at the same load rotation graph with the load rotation relationship, and then we will see the failure criterion of concrete contribution is the blue one. This is where VRC, the contribution of the concrete only with its rotation, is mentioned. Looking at the failure criterion for punching failures within the shear reinforcement region, that was the red curve, then you will see that at a certain load VE, the when you hit the load rotation relationship, you will see that one part of the resistance will be given by the reinforcement, and another part, a certain part of the will be given by the resistance of the concrete only. You will see now in this failure criterion there is a portion where the shear reinforcement is not yielding, and you have a portion where the shear reinforcement is yielding. So it's a quite complex behavior. Detailed verification of the punching shear resistance may be omitted, provided that a control parameter be 0.05 or 0.5, sorry, and that formula 8.87 is valid. This is new. So they say that punching shear, you should not bother when the shear stress is less than a certain minimum value, which is a contribution of the concrete only, T tau RDC min. There is no punching shear reinforcement is required in region at the control parameter B 0.5 when the shear force is smaller or equal to the shear force as a contribution of the concrete. Punching shear reinforcement must be provided in such a way that the shear stress is smaller than the maximum allowable shear stress. This is crushing of the concrete struts. And the applied shear force must be, or the applied shear stress must be smaller than the one provided by the shear reinforcement. Those three last lines is more or less the same principle as applied in the Eurocode 2 version 2004. The first one is new. The big difference is that now the first control parameter is B05, which is the control parameter at at a distance half the effective depth of the slab. In version 2004, it was 2 times the effective depth of the slab. So that's a big difference. The Eurocode 2 version 2023 talks about a control parameter at B0.5 for each step. That's important. We will come back to that a little bit later. It's also stated that a further control parameter, B05 out, shall be checked according to 8447 or 8. So that is the outer parameter. They do not talk about other parameters. It's only B05 and B05 out. The shear resisting effective depth of the slab, dV, which is a new concept, is equals to the one depth in the x direction and the depth in the y direction, and taking the mean of it, the mean value of it. For a direct support, you will see that one is the control section. It's at a distance 0.5, the effective depth. Then you have the effective depth in the y direction and the effective depth in the x direction. You take the mean and you have the shear resisting effective depth. With a hanging support, the effective depth is defined not with the bottom of the lower part of the slab, but with the top of the hanging support, or how do you call this? It's a very small difference. And then again, when there is a penetration, at the depth bigger than the effective depth divided by 20, a direct support, then we have the same case again. You must take the shear resisting effective depth not from the bottom of the slab, but from the top of the penetration. This is not clear because it states d divided by 20. This is not what is d in this case. Should it not be, say, dv or h at the total depth of the slab? So I think this should reach the total depth of the slab, because d is in this case not defined. It's not there. So it's dv or h, not d. Let's talk about control parameters. The B05 of 0.5. First look at an internal column, a circular shape. Then you will see B0, it's the one the closest to the support, and B05 is the one at a distance of 0.5 times the shear resistance effective depth. In the code, those drawings are given, not the formulas. So the formulas are not written in the code. B0, of course, for a circular support is P times D. D is the diameter of the support. And B05 is then B0 plus P times dV. For a rectangular support, B0 is of course 2 times A plus B. A and B are the sizes of the rectangular. And B05 is then B0 plus P dV. You can also have different shapes of columns, but the principle is always the same. 2 is the supporting area, and then you have B0, which is like that indicated, and then the B0.5 at a distance 0.5 dV. For a edge column, 1 is the edge of the slab, and S is the distance between the column and the edge of the slab. You take the middle of it, and that's where your perimeter, control perimeter ends. You put it in a formula, then B0 is 2A plus B plus S, and B05 is B0 plus P dV over 2, with S is the distance from the edge. For the corner column, you have two distances from the edge, S1 and S2. Then B0 is given by this formula and B0.5 by this formula. With S1 and S2, of course, the distances to the edge of the slab. Now, which is nice to notice is that for an internal column, B0.5 is always B0 plus P times dV. For an edge column, B0.5 is always B0 plus P dV divided by 2. And for the corner column, it is divided by 4. So that's nice to notice. For other types of supports, we have the following situation when the support is large in respect to the depth of the slab. It means that the size A and B of the support, when they are bigger than 3 times dV, then you have to apply this rule. You have to, the perimeter is smaller than the total perimeter. It has it can be, the maximum on one side is 1.5 dV. When does this happen? Just to give you an idea, for a slab of 150 millimeters depth, it happens when the support is bigger for a square support than 320 millimeters. For a slab of 300 millimeters, the support must be bigger than 770 millimeters. You will see this is applicable for rather large supports. When we look at the formulas, then the B0 is then 12 times dV because it's the sum of 2 times 1.5 dV times 4. And B0.5 is then B0 plus P times dV. For an edge column, when the size A is bigger than 1.5 dV and B is smaller than 3 dV, then you can also develop some formulas for it. And the same you can do for a corner support. Then there is also correction of the control perimeter when there is a reservation in the slab at a distance smaller than 5 times dV from the control perimeter B0.5. At that point, you have to subtract this portion of the control perimeter. Or you can also have a situation like this one when there are multiple reservations coming together. Then you have to subtract also, you have to adapt your control parameter. In case of slabs with variable depth, in addition to the control parameter near to the supporting area, also other control parameters with their corresponding shear resisting effective depths dV according to figure 8.1 should be verified. Which is important is that they are stating in addition to the control parameter. And then they talk about also other control parameters. So what does that mean? Does this mean that in case of slabs with constant depth, there is only one control parameter? It's an open question mark. It's a little bit confusing. We will come to that. We come back to that later on. So with a variable depth, you see that this is the control parameter 1 at 0.5 dV. It means that the tracks are supposed to be at 45 degrees and not in something like 21 or 22 degrees when the angle is 1/2 with the version of Eurocode 2004. So you apply the same principle for the different slab depths. You will also see here the control parameter at 0.5 dV. For a foundation, it's just the same principle. One is the control parameter, and then you have it at 0.5 dV. And then for dV2, you have also this control parameter 2.